All right, so as I talked about earlier, the rest of the semester looks like this. We're covering these chapters, these 8 sections. Today, we're going to cover section 2.3, chapter 2, section 3, chapter 5, section 1. These go together very well. Exponentials and logarithmic equations go together also because they're inverses of each other. Once you learn what they are, then the properties fits in, and then we can start solving equations and how you can use logarithms to solve exponentials and vice versa. And we'll do that on Monday. Next Wednesday, we're only going to cover chapter 6, systems of equations, and it'll be the last thing we cover. That's as far as we get in the semester. And then Thanksgiving, I want everybody to spend your time taking your tests, catching up on your homework and everything. So I want that is already set. When we come back, we'll review. All right. Composite functions. Chapter 2, section 3. Composite functions. What does composite mean? It's like compound, but composite means something, when something is composed of something, it's made up of multiple parts. Well, no, yeah, you're getting ahead, yeah. But I'm talking about here, it's basically what this means is a function within a function. A function is composed of a function. It's composite. So what does that mean? We have 2 types. Sometimes you'll hear the people talking about, when they talk about algebra, they talk about what's called the fog and Goff. About time. So what this means is f of g or g of f. Whenever you hear people talk about fog and Goff, that's what they're talking about. It means one function's inside another function. So what this means, remember they're functions, so they have to represent with x. This is read, this one's read f of g. That little O there is the word of. What it means is the function g is the input, is the variable for the function f. Is the input. That's the function within a function. Okay, it looks ugly, but it really it's much easier than it looks. Okay, before you got here, we talked about what we're going to cover the rest of the semester. These are them. Today we'll cover these 2, and then Monday we'll cover these 4 because they go together well. And then next Wednesdays are pretty much the last lecture day, and we'll cover these. And then after that's Thanksgiving. Well, if you want me to come on Monday at Thanksgiving, I can. But I'm hoping everybody takes Wednesday off. Okay, if you want me to come on Wednesday, I'll come on Wednesday too. Okay. Okay. And then when we come back from Thanksgiving break, I just want to spend those last 2 days reviewing over everything. So, and then you guys take the final exams anytime you want to. All right, so let's look what this means. Fog and Goff. We have a function Let's say it's 2x plus 3. That's function f of x. The function g of x is, let's just call it 5x. Remember when we first started talking about functions themselves, how this is read? This is read f of x. What it means is the function f with variable x. That's what that means right there. The f in parentheses x. It's read f of x. It means the function with the only variable we have is x in this case. So far, so good. So if I said find me fog, F-O-G. What that means is the outer function and then the inner function. So what is the outer function? F of x is 2x plus 3. But in place of x, we have to put g of x. So this is 2g of x plus 3. And what's g of x? G of x is 5x, so I just put that in there. And then you work that out. 2 times 5 is 10, x plus 3. And this is my answer to this question. Another way you could look at this, since I have the 2 letters here, whatever letter comes second, that equation goes in place of the variable of the first letter. That's all it tells us. Okay, with the same functions, find me Goff. With the same 2 functions. As we know, f of x is 2x plus 3. G of x is 5x. So what is this really telling us? Right. So it's telling us, since the f is this inside function, so whatever this function is, goes in place of x in the outer function. So what that says is 5 times 2x plus 3. Then x plus 15. And there's that answer. Again, with the same 2 functions, find me these 2. Foff and Gog. It sounds weird, but you can tell who's been through college algebra. They understand what these, when you say Foff and Gog and Foff, they know what you're talking about. Other than that, it sounds like you're making up words. So what's this one going to look like? Well, this is F inside F. So anywhere I take this equation, anywhere I see an X, I put it inside there. So it's 2 times 2x plus 3 plus 3. Because the function F goes inside to wherever the function is. Two times 2 is 4x. 2 times 3 is 6 plus 3, 4x plus 9. That's that one. And then do Gog. So the second one says it's G inside of G. No, it's, well, what is G? It's 5x, right? But the variable is gx. Right, it'd be 5x, 5 times 5x, because the variable changes to G, which makes it 25x. So far, so good? An application of this, and how we can use it. But now I'm going to use the same two equations, and this time we're going to find it for a value. We're going to find all 4 of these. Pick a value of x, any value, positive, negative, or 0. 2. Okay, good job. See? So if x equals 2 and f of x equals 2x plus 3 and g of x equals 5x, find fog of 2, goff at 2, foff at 2, gog at 2. So let's see what this really means in the first one. Fog. And that's, remember, that's the same thing as what this means. So what this really tells us is what? What is G of 2? Yeah, so since G of X is 5 times X, in place of X, I put a 2. So that means it's 10. So that means what I have here, my input is 10. And the function f of X is 2x plus 3. So anywhere I see an X, I put a 10. So this answer is 23. You have to work inside out, order of operations. What is G of 2? Well, the function G is 5x. So in place of X, I put a 2. 5 times 2 is 10. So now this becomes 10. The function F says 2x plus 3. So in place of X, I put a 10. 2 times 10 plus 3, and work it out. Do the same thing with Goff. You have the functions there. So what is, how can you rewrite this equation? G of F. So it's G, the of means it's inside the parentheses. So the first thing we have to do is figure out what this one is. What is F of 2? F is 2x plus 3. So it's 2 times 2 plus 3. 4 plus 3 is 7. So what this tells me so the first thing I got to do is find out what F of 2 is. Once I find that, I plug it back inside here. The function G is 5 times 7. 35. And there's my answer. So do the same thing with Foff and Gog. At 2. Okay, so what's the first one gonna look like? FOF. We have to set it up. So we have to first find f of 2. So go to the function f, anywhere c and x, I put a 2. So it's 2 times 2 plus 3. So that's 7. So now, since f of 2 is 7, this value now goes inside here. I repeat the process, f of 7. 2 times 7 plus 3. 14 plus 3 is 17. There's the answer. And lastly, GOG. G of 2. In place of x, this is the x, I put a 2. 5 times 2 is 10. So G of 2 is 10. So G of 10 is 5 times 10, which is 50. Does it make sense? Because it's just plugging one function inside another, or a value inside another. Let's try some bigger ones. F of x is equal to 2x minus 5. And now g of x is a quadratic equation. X squared minus 3x plus 8. Find these values. There, find these 4 values. Yeah. Make sure everybody's on the right track. So the first one, we have f of g of 7. We first have to find g of 7. Yeah, so anywhere see an x and g, we put a 7. 7 squared is 49. 3 times 7 is 21. 49 minus 21 is 28. Plus 8 is 36. That's just what g of 7 equals. So I have now f of 36. Because we know that g of 7 is 36. Now I have to go back to my original equation for f. 2 times 36 minus 5. 72 minus 5 equals 67. And there's that answer. So far, so good. Let's try number 2. Off at 7. So first thing we have to do is go to find f of 7. That's 2 times 7 minus 5. 14 minus 5 is 9. So that goes in place of g of f of 7. G of 9 is 9 squared minus 3 times 9 plus 8. X squared minus 3 times x plus 8. 9 squared is 81 minus 27 plus 8. 81 plus 8 is 89 minus 27 is 62. So far, so good. We're doing FOF of 1. So f of 1 is 2 times 1 minus 5. 2 times 1 is 2, minus 5 is negative 3. Again, don't just copy what I'm doing. Work it out first. Because all this stuff here is just plug and play. We should know how to do this already. So the answer is negative 11. Again, all you're doing bobbleheading, you should wait till you're finished, then look at the board. Unless if you're not sure what you're doing, then ask me questions. Okay, we have one more. We have GOG at 1. GOG at negative 1, which is g of negative 1. So g of negative 1 is negative 1 squared minus 3 times negative 1 plus 8. Negative 1 squared is 1, negative is a positive, 3 times 1 is 3. 12. So g of negative 1 is 12. Twelve squared minus 3 times 12 plus 8. 144 minus 36 plus 8. 144 plus 8 is 152 minus 36. 116. Okay, so much for easy functions. What happens if we have, go back over here and look for uglier ones. What if we had something like this? How would you do fog and Goff here? No, just X's, just combine them both. What this one says, this one goes inside the f of x. In other words, this equation, the g of x, goes inside the f of x. So anywhere I see an x, it goes there. So it's there. Conversely, what this one says is the f function goes in place of x in the g. And there you have it. What if we had fractions? Again, what this one means is the g of x goes inside the f of x. So this huge equation here, that's my g of x, that goes in place of x. Are we done? No, because we have a fraction over a fraction. So it's 1 over 1 over 4 over 1, or 4 over 1 minus 5x. Since this is a fraction already, I have to make the top into a fraction. 1 is the same thing as 1 over 1. You have a fraction over a fraction, take the top fraction, leave it alone. Take the bottom fraction and flip it. Nothing cancels. So we have 1 minus 5x over 4, and that's your answer there. That's the g of x put in place of x on the bottom. I have a fraction over a fraction, so I got to flip the bottom and work it out. The second one, I take my f function, anywhere I see an x and the g, I put it on the bottom, or put it where it is. So it's 4 over 1 minus x is 1 over x. Five over 1 times 1 over x is 5 over x. We have to fix the bottom first. We have to combine them because they're fractions. What's the LCD? X. So this one is an x over an x. So it's x minus 5 over x. Everybody okay with what I'm doing so far? I'm working on just fixing the bottom first. Because I had 1 minus 5 over x. I have to get fraction minus a fraction. LCD, they're both x's. So I have x minus 5 on top over x. It's a fraction over a fraction. 4 over 1. So take the top fraction, leave it alone, and multiply it by the flip of the bottom. Nothing cancels. So we multiply. And there's your answer. It takes practice with fractions because you have to worry about each part separately. You okay with this? Let's go backwards. Decomposing functions. So let's pretend we had this equation, 2x plus 3 to the 5th. You see two functions inside there. In other words, can you define an f of x? And can you define a g of x that makes up this equation here? Basically, what we want is h of x is going to be a composite function. So what do we see anything on the inside? So the inside is 2x plus 3. And it's encapsulated by this one, which is x to the 5th. There's your decomposing of the two functions. Now, why is all this stuff important we're learning here? Because in chapter 5, in order to know if a function is an inverse of another function, that's the next thing we have to do is talk about inverses. If f and g are inverses of each other, what do I mean by inverses? X squared versus that. These two functions are inverses. Why are they inverses? Because if this is my f and this is my g, what would happen if I put it in there? So this would be f of g of x. So my g of x goes inside there. Now that goes inside my other function. So it's what happens to square root and square? They cancel. Because it equals x, we know that these two functions are inverses of each other. If they're truly inverses of each other, this also should equal x. So f of x is x squared. If we put x squared inside that, x squared and that cancel, so we're left with x. So that's how you can prove that these two functions are called inverses of each other. In other words, they cancel each other out. And that's why we have to be very, very strong in this Fog and Goff stuff, the composite functions. So far, so good. That does it for chapter 2. And unfortunately, I have to cut class short today because my father passed away yesterday, and we have to go and get everything ready for the funeral Friday. So, I mean, my 3 brothers and I were around his bed when he passed away, which is super glad that we got to do that.